Hello there. It is time to graph another rational function. Alright, so step one, let's get that numerator and denominator into factored form. So this one's taking a little bit longer than usual. The top you can factor out an x, the bottom you can factor out a 2, and then it becomes a little bit more manageable because you just have x squareds. Top's the difference of squared, so let's do that. Okay, so can we create an f hat version of this? Nothing is matching in the top and bottom, so we're not going to be able to reduce and make this smaller. That also means that there are no potential holes. There are going to be no holes. So our domain here is everything not equal to either 3 or -1, and those are also going to be our vertical asymptotes. So convenient, this one had no holes. Okay, looking at the top, that numerator, when does that equal 0? Those are going to be our x-intercepts. And then we can plug in a 0 and figure out where our... Oh, actually we have one more x-intercept. I missed it. Haha. Yeah, it's this one right there. Forgot that one. So we also have one at 0, 0. And that's consequently also our y-intercept. I knew there was reason for doing this problem. Okay, so we can begin to get part of the shape involved in this thing. So vertical asymptotes at 3. I'm going to have the squares go up by 0.5s again. So here's going to be the 3 and -1's back here. And then we have those various x-intercepts, -2, 0, and +1. I just got really confused here of how this thing's going to have to look. And that's because I have not yet considered the end behavior, which is going to be a horizontal asymptote, but actually this one is going to be case 3, because you have a cubic over a quadratic, and that cubic's going to win in the long run, so this is going to go up to infinity and not settle near 0 or any other number. So to figure out the equation of the oblique diagonal, we're going to have to do some polynomial division. So I'm building a little bit of space in here. Now remember that this is what's being divided, and this is what I'm dividing by. That's why we put this one on the outside. If you reverse it, you actually know immediately that it's not going to go in. So you got to do it this way, because this has to be some kind of line. So I need to get up to x cubed. I have 2x squared. I'm going to need 1/2 x. Okay, so this is what we're subtracting, and maybe I'd rather prefer canceling with addition. So make that negative, make that positive, make that positive. And now I got to get up to 2x squared, and that's going to require a +1. And at this point, I'm going to have other stuff. There's going to be some kind of quotient so it gives it its shape. But that's the equation of my oblique asymptote. And I can, for these kinds of problems, I can actually just kind of quit there. And then we'll want to graph that too. Okay, so this is kind of interesting too, because it also seems to go through, that oblique asymptote goes through this x-intercept. And that's what we talked about. That's okay, that the graph can touch the asymptotes at certain points. It's just a behavior in the limit, really, that it's approaching it in the limit where it can't touch it. Okay, so now I have a challenge of trying to figure out what sides this curve's going to be on. I have to treat these as asymptotes. I have to weave it through these points. I have to somehow get it near approaching this line here and this line here in the end. So maybe it's a question of, like, do we drop in from the top here, or are we coming in from the bottom? Well, I know that I actually can't be coming in from the bottom because there's no x-intercept out past here. These are the only x-intercepts. So this one's got to come in from the top. And my y-axis on this is not actually going to be accurate, so maybe this is shifted further up. I'm not really sure, but it is going towards that line there. So I'm just trying to get the shape here. We could plug in points to figure out where exactly it is, but that's not something we're going to do, not something we're going to be required to do. This line actually is important to have accurate. Okay, This is not what we're going to call a volcano. We're not squaring this x minus 3, so it's not going to drop in from the top. It has to come in from the bottom, and that kind of makes sense. It's going to come in from the bottom, go up, hit this point, and then come back down. And again, the negative 1, asymptote's not a volcano. It's not being squared, so it's going to drop in from the top, and it's got to go through this point, but then it has to treat that as an asymptote. So it's got to like go through this point, go down a little bit, and then come back towards that line. So you wind up getting these strange looking things, and it seems like it's news break time. So we're going to end this video. We've already ended this video. We've gotten all the major points. X-intercepts, Y-intercepts, oblique asymptotes, vertical asymptotes. This one didn't have any holes. Okay, character and scholarship for life.